So here we're going to be covering section 2.6, and this is going to be working with solving for a specific variable. Now, up till now, we've been working with problems where we have some variables written in for us, we have some numbers written in for us, and if we're told to solve for x or solve for y or solve for something like that, it's the only variable that we have present in the problem at the very beginning of the problem or as we're going through and working on it. So this section is where we're going to start deviating from that. We're now going to start solving for a specific variable with multiple variables in the problem. So we'll go through our general idea of how we're going to go through that, and we'll go through some examples comparing where we have numbers written in and where we have variables written in as well. So our process or our general idea is when we're solving for a specific variable, this is something that a lot of people do not do, and I want to emphasize this as much as I possibly can. Determine which variable you are solving for. If you're looking ahead on these, we're seeing, okay, I've got 1, 2, 3 variables showing up here. I've got 3 here, 3 here, 3, 2 here, but we're going to have multiple variables showing up in these problems. And we can and might see in future ones, we might have 4, 5, or 6 variables showing up in these as well. So make it abundantly clear to yourself on your paper, scratchwork, wherever you're going and writing these things down for yourself, which you should also be doing. Make it clear what variable you are solving for. If we're looking at our first problem, am I solving for A? Am I solving for B? Am I solving for H? It could be any of those things. Make it very clear what you are solving for on your own paper as well. Now, a lot of people think with this, and it's understandable, that we have very specific rules that we need to follow when we're solving for variables versus when we are solving for numbers. It's understandable, but here's the really nice part about it. We can use all of the rules we have for adding, subtracting, multiplying, dividing variables just like we would with numbers. So any other variable that we see showing up in this, we're just going to treat that as if it were the number 3 or the number 2 or anything like that. So all of our previously established rules for solving equations are going to apply here the exact same way. Except it just so happens that we're going to be applying those rules to a symbol that we denote to be a variable, compared to a symbol that we denote to be a number. And we'll go into that as we're seeing when we compare our methods with a specific variable and a general variable. Or with values and variables, I should say. Now, the warning that I want to give you guys on this as well, this is a very common mistake. It's understandable, but it needs to be stated. We cannot change a variable from upper to lowercase or vice versa. If we're choosing to do that, we're going to get wrong answers, primarily due to the fact that we do have equations in mathematics that utilize all within one equation, an uppercase a and a lowercase a. And both of those variables, the upper and the lowercase one, have extraordinarily different meanings attached to them. So if you swap them back and forth, well, that uppercase, I'm just going to write it as lowercase a. That lowercase one, I'm just going to write it as an uppercase. You cannot do that. Errors occur, specifically when we get into actually solving and working with story problems with that as well. So if something is written uppercase or lowercase originally, you have to keep it written that way throughout the entire problem. You cannot deviate from that in any way, shape, or form, or you're going to get wrong answers. Okay? So keep the variables exactly as they are written. You can still add, subtract, and multiply and divide them to both sides of an equation. That's fine. But again, the upper lowercase has to stay the exact same as it was at the very beginning. So we're going to go through a couple examples with this. Now what I'm going to do, and we can see the answers written in here, let's pretend we don't actually see those. So we're going to go through and we're going to solve our first example that we have here. And I wanted to show the comparison with the processes. So I'm going to go with the one that we have seen up till now. We've been given an equation. We're told to solve for a variable, and then we solve it with values attached in. We're then going to go through and we're going to compare the exact same thing, but with no values written in. So I do want to show us the comparison between our two processes and how they may look different, but we're actually doing a very, very similar thing in both of them. So I'm going to do that with each of these. So when I jump us over to our whiteboard, these are the 4 equations that I am referencing for that, just so you guys can have a quick look at them before we jump on over. Okay, so we'll take a look at those now. All right. So our first example that we have been given, again, we're going to go with the numerical example, and then we'll go with the general example directly after that. So our first problem that we have been given the equation A equals 1/2 B times H, or the area equation for a triangle. So we are told in both of these instances, we are going to be solving for H. So when you are going through and writing this stuff down on your paper, I would highly recommend that you do this. Actually write that out for yourself. You could do for H. You could do, and I've seen some people underline it a few times for themselves, as some people just circle something like that. Make it abundantly clear for you what you are solving for. Again, it seems like, well, okay, that kind of seems like it might be overkill to do that. Trust me, it isn't. It's absolutely worth doing. So let's work with our first example with numbers first, and then we'll go with the general one. So let's work with. So again, the first part that we had, we were told to solve this equation for H when A is equal to 18 and B is equal to 6. Okay. So the first thing that we're doing with this, I'm going to rewrite the general equation right below it. And I'm going to substitute in what I've been given. So that 18, or that A value, variable A, is now 18. 1/2. I've been told B is equal to 6. And I still have H there. So now we can go through and we can simplify each side of the equation before we start adding, subtracting, multiplying, or dividing things together. So the left side, I cannot simplify the number 18 any further. The right side, I have 1/2 times 6. It's going to give me 3. H is going to stay there. Now, I don't want 3H, I just want regular H. I want to divide both sides by 3. On the right side, it cancels. Now you have 6 equal to H, and I just like to write the variable on the left side for me. So we have our answer there. Again, it's working with numbers. This should be review, very similar to what we did and worked with in Math 70. And now we're going to get to the instances where we have, I'm going to put this in the general one. So we had numbers, and now we're going to work with solving this in the general sense. So this would be that second block down if you're looking at the notes that we have here. We have not been given a value for the base, the area, or the height. But we are still solving for H. So we're solving for H here. We want to get H all by itself on one side of the equation. That's, again, the general idea of what we're doing here. Now, again, a lot of people will take the fact that we do not have many, if any, numbers showing up in here as the sign of, I need to do something special with the variables. They have special properties attached. They have special rules attached to them. They do not. You can treat the A on the left-hand side, again, as if it were just a number. Treat the B as if it were just a number in terms of how we are going to be able to add, subtract, multiply, or divide it to both sides of the equation. We do not explicitly assign it a number, but again, we're just going to think of it as though it had some value attached to it. 2, 3, 5, 10, your two favorite numbers. And we're going to leave the H because, again, that is the thing that we are solving for. So the H needs to stay. It's going to be actually left as a variable. We're going to think of that as a variable. But everything else, we're going to think of it as a number. So looking at this problem in the general sense, I want to get h all by itself on one side of the equation. And you have multiple options on how you can get to that end with what we have written out for us right now. Multiple options, all of them will work, just making sure you're being very methodical with that. So let's work with something that I think we're all fairly comfortable with working with up to this point in time. Let's get rid of that 1/2. Let's work with the numbers first. I do not want 1/2 times the base times the height on what side. I just want the h all by itself. So how would I get rid of that 1/2? Well, I'm going to multiply both sides by 2 to get rid of that fraction. So I'm going to take the left side, multiply it by 2. I'm going to take the right side and multiply it by 2. It's kind of crossing over there, but right down below here. So I've successfully gotten rid of the 1/2 on the right-hand side, so now I only have one thing attached to the h, which is good. I have the 2a over on the other side. Great. I don't care how nice, gross, terrible, beautiful the left side looks. I just want h all by itself. That's our goal here. And then I want to get h by itself all the more. I do not want this b attached to it. The b is attached through multiplication. I undo multiplication with division, so I'm going to divide both sides by b. And again, I'm writing this in, and I'm treating b as if it were just a number. We actually write it out as a variable in terms of it having the a or the b or anything in there. But again, we treat it how we add, subtract, multiply, and divide it to both sides as if it were just a number. So as we're seeing here in terms of how we are, my little highlight spotlight, there we go. So in terms of how we are dividing things on both sides, not much is changing. We are just using these symbols instead of these symbols. And again, we're going to get more often than not as we're going through problems like this, we're going to get a lot of problems and answers that are going to have variables left over inside of them. That is okay. There's nothing wrong with that. It's actually expected to happen more often than not. So it's going to take a look at example 3. We're going to skip 2 because I think it's a pretty good straightforward one, but we want to walk through a couple of these a bit more complex ones. That way you have some tools to reference when you get to the more complex ones on the homework. So our third example we had, again, we're just jumping ahead here a little bit with these ones. We have 3x minus 2y is equal to 24. And I'll show you guys another way that I've seen people organize this for themselves. So you write out the original equation. What are we solving for? And the problem always has to tell you what variable you are solving for. On the test, if I give you this, I have to tell you solve for x or solve for y. I have to tell you that. It is impossible for me to give you guys this equation and say, solve it. Because your question would be, well, solve it for what? And no one's a mind reader, so it has to be stated to you what you guys are looking for. So for this problem, we are being told to solve for y. So if you want to write out for y off to the side, I've seen some people do that, something to that effect, so it makes it clear to you what variable are we looking for. So organize that how you see fit. Again, we're going to do this side by side. Work with the instance where we have numbers first. This is that first kind of chunk of the practice problems. So we're told to solve for y when x is equal to 6. Okay. So again, our first line of work, write out the general equation again. And then substitute that variable or that value in for the corresponding variables. We've been told x is equal to 6. So we have that written in there. and then we're going to solve this out accordingly. I did see a quick ping of something in chat. Give me a second here. We'll solve through this, and then I will get to those questions there. So again, we are solving this thing for y, just like we have done in all of our previous assignments, all of our previous work. So substitute in 6 into there, simplify both sides down, we're good there. I want to get the y, or the variable terms, all by themselves, so I'm subtracting 18 from both sides. This cancels over here. And then I do not want negative 2y, I want just y. So divide both sides by negative 2. Negative 2's cancel. And I get y is equal to negative 3. Positive divided by a negative is going to give me a negative answer. Okay. So again, this is in our specific example where we have numbers showing up. It should be a review, very similar to what we've seen in previous quarters. And now we're going to work with the general scenario. So again, I would highly recommend when you are going through this, write out the original equation. Before we do anything else. We've got the general equation written out. Now we're going to solve this thing for its corresponding variable. So again, we have been told we are solving for y. So I'm going to treat any and all other variables in this problem as if they were just numbers. So that 3x that's attached to it, that might as well, it's 3x over here, that might as well be 18. It might as well be the number 20, it might as well be the number 50, whatever it may be in that regard. We're going to treat that as if that is just a number. So I do not want that on the left side of the equation. I want the y all by itself. So I'm going to subtract 3x from both sides. Cancels there. I can't combine the 3x and the 24. They are not like terms, so they have to stay separated, which is fine. And now we are going to get rid of that negative 2 attached to the y. That negative 2 is attached through multiplication. I undo multiplication with division, so I'm going to divide both sides by negative 2. Now, when you are doing this, you have two ways you can write this out for dividing both sides by negative 2. You can either write this out, and I'll put this right next to it as the alternative. You can write this out as the entire right side divided by negative 2. Or, I think this is the one that a lot of people prefer to use, but it's your choice. So if I divide the left side by negative 2, I say I want the first term divided by negative 2, and then the second term divided by negative 2. Either of these two ways of writing that out are perfectly acceptable. It's your choice in which one you would like to use. There are advantages to some, or to one of them over the others, and that will very much depend on what problem, what numbers we have been given. So some instances, it might be nice to have one single fraction on the left-hand side. Other instances, it might be nice to have it separated out, so I might have a fraction here and a fraction here. It's very dependent on the problem. You can also go back and forth between these two forms as well, if need be. But either of these are acceptable to go through and divide both sides by that negative 2. It's your choice. I'm going to be using this instance over here in our next line of work, but again, you can get to the same thing with this work over here. So once I've divided both sides of this equation by negative 2, on the left side of my equal sign, I'm just going to have y left over. And on the right-hand side, again, I'm referencing this instance over here. I have negative 3x divided by negative 2. A negative divided by a negative is a positive. 3 divided by 2 doesn't work out to be a particularly, I mean, it's kind of a nice decimal, but I'm going to leave it as an improper fraction. It works out to be a positive 3 over 2x. And then 24 divided by negative 2, that's going to give me a negative. Positive divided by negative is a negative. 24 divided by 2 is 12. And I can't simplify that any further. I have y equals on one side. Good to go. Oh, it didn't like that. Okay. Take 2. There we go. And now I have it written out in the general sense. So again, there's a lot of similarities with how we can add and subtract and multiply and divide these things over. The only difference is, again, now we're going to have a variable thrown into the mix. But again, we can treat that as if it were just a number. Okay. So we're going to go to our fourth example we have here. And again, I'll zoom us in. I just want to make sure I have enough room to work with this thing. Okay, so our fourth example, the equation that we have been given is B is equal to 2L plus 2W, the perimeter of a rectangle, the perimeter of a square. And we are told to solve this thing for L. I'm making a note of that. So I'm solving for L. It's explicitly clear we know what we're solving for. So again, we'll work with the specific case where we have numbers showing up. And again, up till now, we're just following the same process. We have been told when P is equal to 22 and when W is equal to 5. So again, just like our previous examples, I'm hoping we're seeing where this can be very, very mechanical, and it is. We can, given values, write it down, write the equation, and then substitute in what we have been given. Let's make those twos a bit better. There we go. So we're substituting 22 in for P, subbing 5 in for W, and now we're just solving this thing like we've done in previous problems in the past. Nothing particularly new, nothing particularly fancy about this. It's a process that we have seen. Should be pretty comfortable with at this point in time. So again, we're dividing both sides by 2. We want to get L all by itself. Oops. 2's cancel. And we get L equals 6 on the left-hand side. So again, similar process to everything we've done up to this point in time. We're just substituting things in and then solving. So now in our general sense, we're only going to have variables showing up at this thing. So again, same idea. Sure, there we go. So we have our general equation. And again, we are solving for L. So all other variables in this problem, we're just going to treat them as if they are just numbers. Don't know what those numbers are, that's fine. You can, in your head, imagine it's the number 2, 3, 10, your favorite number in there, or your 2 or 3 favorite numbers in there. So again, we're solving for L, so we want to get L all by itself on that one side of the equation. So I need to get rid of this 2W. over there. So I'm going to subtract 2w from both sides. On the left side, I'm getting p minus 2w. On the right-hand side, I'm just left with 2l. And again, now we need to get the L all by itself. I need to divide both sides of the equation by 2. So I'm dividing by 2 here. And again, I'll show you guys the 2 ways you can write this out for yourself. I'll put 1 over here. And I'm just showing the other way you can write this out. Just off to the side. So I divide that by 2. I divide the other side by 2. And when we do this, I'll show you guys our 2 possible answers that we can get from this. The 2 possible ways of writing the answer, I should say. So we can get either of these 2 answers at the very end of our problem. So when you are going through and working on these on the homework or on the test or anything like that, and you are checking your answer, I think this was pretty common in the textbook, especially if you were doing some of these. So if you're doing the textbook problems as additional practice, so some ones like these, which is fine, be aware that just because you have it written one way in the book says the answer is this other thing, you may be able to rewrite and simplify things down to be written in that form. We could technically go back and forth between either of these 2 answers. If you were to combine these things together to be a single fraction, you could rewrite this term to have a common denominator of 2 and then combine them together, at least the numerators together, and you would get to here. If you wanted to separate this out into 2 separate fractions, or separate terms, you would take the first numerator, the first part of the numerator divided by 2, minus the second part of the numerator divided by 2, and you'll get to this answer. So we can go back and forth between these 2 terms as we see fit or as we need to, these types of problems. So if you were going through the homework and it's telling you, let's say you work it out this way, and it says, no, this answer is wrong, it's incorrect. Okay, well, hold on. Just take a quick second and say, okay, let me try, see if I can rewrite it into a different form. Maybe it wants this form instead. You rewrite it into that form, try this one. Maybe it'll say, okay, yeah, you're good and correct. If it doesn't, then maybe we have an error showing up. So I just advise a little bit of caution with jumping to the conclusion of, WAMAP says I'm wrong, so I'm clearly wrong, and I obviously can't be getting it correct. Maybe not. Maybe that it's being extraordinarily picky, which is not unreasonable. It's being really picky about what it wants, and it's not telling you that explicitly, which does happen from time to time. So again, just be aware of that as you're going through these things. Just because it says you're wrong does not inherently mean that you are wrong. Okay? So these are our 3 examples that went through with these. There's another one that I think number 2 isn't too bad, but it's essentially number 1 again. So I want to give you guys a bit of variety in what you could see. So these are our examples that we have, and this is pretty much everything for the 2.6 material. Again, the biggest part to take away from this, if you are solving for something in the general sense, where we do have variables showing up in there, treat all other variables that you aren't solving for as if they were just a number. You can add, subtract, and multiply them together as if they were just the number 2, or the number 5, or the number 10, or anything like that. There are no inherent special properties that go along with that. And also be aware that you can and you will have answers with variables showing up in them, like we have here. They're general problems that we worked with. There is nothing wrong with that. It's to be expected when you go through these. Okay? So with that, I'm going to end our recording here. I'll take any questions that you guys have after that.